Hello, problem solvers. Here is a geometry problem. I saw this from the Mind Your Decisions channel from Walker. I would like to present my solution, but before that, please give it a try. So we have a parallelogram, and E, F, G, H are the midpoints, and if you connect the midpoints to the vertices, you get the intersection, you get an octagon, and we have to find the area of the octagon in terms of the area of ABCD. So for example, if we let the ABCD to have area 1, what would be the area of the octagon? Please give it a try. So if you watch the channel Mind Your Decisions, Walker said that this is a problem, a geometry problem for the 8th grade in Russia. In the 8th grade, you are not taught much, but I think in the 8th grade they have been taught about the method I'm going to show you. So because in the 8th grade they have taught this method to students in China as well, so I guess by the 8th grade Russia, good good students at math may know about this. Anyway, let me show you. Maybe I'll just let you see it in action, how area ratio works. So let me call this point P. Okay, and let me call this point Q. So you see EG are parallel to BF, okay, and EP are the midpoints. E is the midpoint of AB, P is the midpoint of AF. So EP is half of EF, right? So if this is K, this would be 2K, and the whole length is 4K, right? So that means, that is my first observation, EP to PG is 1 to 3, right? Because I just told you, if this is K, this would be 2K, this would be 4K, the whole thing would be 4K, this is K, so this would be 3K. Okay, so the ratio of EP to PG is 1 to 3. Then we look at triangle AQD and triangle PQE. Okay, this small one and this big one. Again, EP, AD are parallel and they have opposite angles, so they are similar. Okay, they are similar. And I just said that EP, so EP to AD is 1 to 4. Right. So first of all, I just argue that they are similar. And secondly, I just told you that EP to AD is 1 to 4. That means all the other side lengths should have a ratio 1 to 4. That means PQ to QA is 1 to 4. Okay. also EQ to QD is also 1 to 4. QD is also 1 to 4. Because I told you we'll make use of area ratios. So whenever we use area ratios, we need to use the ratios of segments. So that's why I'm pointing out all these segment ratios. Okay, but if you, let me call this point, let me add another point. Let me call this point R. So far we know that EQ to QD is 1 to 4, but I want to find out these, let me call this SE. I want to find these segments, the ratio of these segments. So next, let me call this length EQA. Actually, let me call it 2A. I need to call it 2A. EQ is 2A. So QD would be 8A. 8A, 1 to 4, right? But notice DR to R is the midpoint of ED, because this is parallelogram, the diagonals bisect each other. So DR is half of ED. Okay, if EQ is 2A, QD would be 8A, the total ED would be 10A. DR is half of that, so DR is 5A. Okay, DR is 5A. That would be like 5 of. Let me just say that. So let EQ be 2A, then DR is 5A, and RQ will be 3A. Okay, because RE is 5A, this is 2A, so RQ is 3A. Okay, we need one more ratio. I need to find out RSE and SQ. Okay, I need to draw one more line. I will connect R to H. So of course I just connect their midpoints, then HR is parallel to AB. Okay, I told you I want to find RS to SQ. We will do that, but let's look at two similar triangles, HSR and BSE. So these two are similar because HR, AB are parallel, right? So HSR is similar to BSE. That means RSE to, so also you know that HR is half of EB, right? This length is half of this length, right? Because this length is equal to this length, this is half of this. Okay, so HR is half of this. So they are similar. So the lengths, the ratio of their lengths should be in 1 to 2. Okay, and so that tells me RS to SE is 1 to 2. Okay, so if RQ is 3A, this is 2A, I want to find out RS, you can do the math. Okay, so how? Well, let's just call RS is XE, then SQ is 3a minus xe. So rs to se is 1 to 2, but if I call rs to be xe, then se is 2a plus 3a minus xe. Okay, and you can find out x will be 5a over 3, 5 over 3a. Okay, so that is RSE. So RSE is 5 over 3a, and then SQ will be 3a minus that, 4 over 3a. Okay, so now we have all the required line segment ratio. Okay, so all I care are this ratio. Okay, you see EQ is 2a, so RS is like some multiple of EQ. Okay. Now let's get to the area. Let's start calculating area. Okay, so first of all, the total area is 1. ABCD has area 1. What about EAP? Let's start calculating here. What about area EAP? Well, EAP is like 1/4 of this, which is also 1/4 of this whole parallelogram. So that would be 1 over 16. Here comes the first application of area ratios. So I know that EAP is 1 over 16. I want to know the area of AQE. But I know that AQ to QP is 4 to 1. Right? Somewhere here. Yeah, AQ to QP is 4 to 1. Then if the total area is, so the area, what does area ratio say? Let me just do again, say some, let me just say some here, mathematical Olympiad facts. Okay, this is about area ratio. So the key is that, let's say you have a triangle, and you have some line segments like these. Okay, so let's say the ratio, of this segment is A to B. Okay, then the area is X and Y, then the ratio of the area is just A to B. This is ratio. Okay, why is that? Because they have the same height. Okay, you can think of it this way. X, Y. What is X? X is half of base times H. Half of base times H. These cancels. Okay. So whenever you have two triangles with same height, and you know the ratio of the base, then the ratio of the area is just equal to the ratio of their bases. Okay, we call this same height triangles. There are actually several area ratio facts like this, but this is the most straightforward one. Okay, so that tells me, because EQP and EAQ are same height. That tells me the ratio of the area, is 1 to 4. The total should be 1 over 16. If this, let's say this is K, then this will be 4K, and then total will be 5K. 5K is 1 over 16. Okay, that means area of EQP would be 1 over 16 divided by 5, which is 1 over 80. And EAQ would be 4 of this, which is 4 of this, which is, let me just type 4 of 80, okay, instead of 1 over 20. Okay, let me just keep it same. That would be easier. Maybe anyway. Okay, of course, by you can argue it, or you can argue this length, and this length is also 1 to 4. It's same, okay, and you will find that this is also 1 over 80, and this is 4 over 80 as well. So this will be 1 over 80. Okay. Okay. What about let me call this T. Okay. Once I find out all these area, okay, then I'm done. These three, because by analogy, you can also find out these, right? If you look at ABT, triangle ABT, compared with AD, this point, ADXE, okay, this is like kind of, they have the same how to say, same they will have same area. Okay. You can do the same reasoning, okay, to argue that. And actually, by same reasoning, you can also find out that this is 1 over 80, just like these. Okay, this will be 4 over 80, 4 over 80. So let's find out all these three areas. So here, consider the triangle DHSE. Here we have two same height triangles, HSR and HRD, same height, right? HSR and HRD. So and I also know the ratio of their length. DR is 5, DR is 5A, and then RSE is 5 over 3A. So the ratio is 1 to 3. Okay, 1 to 3. That means the area of HSR and HRD is also 1 to 3. Okay. So if I know HRD is 1 over 16, HRD is 1 over 16, that tells me HSR is 1/3 of it. So 1 over 48. The whole thing is 1/48. But I also know that HTR is 1 over 80. So I can calculate, I can subtract and find out TSR. Area TSR will be 1 over 48 minus that's 1 over 80, and it will give you 1 over 120. T over AD ATSQ. Okay, this quadrilateral. Okay, but it's easier to include this part and consider ARQ. ARQ and AQE same height again. Okay, so RQ is 3A, this is 2A, so the area ratio is 3 to 2. Okay, so that means this would be ARQ would be ARQ. Okay, include this part would be 6 over 80. Include this part. Okay, so subtract 1 over 120. Okay, whatever that is. Okay, you get 1 over 15. Okay, and actually you can find out this one just by same reasoning. If this is 1 over 120, this will be 1 over 120 as well. If you don't believe me, okay, you can try to compare this area HSR with SEB. Okay, this is the length. These two are similar triangles, not same height, but similar. That means if the length is 1 to 2, then area is 1 to 4. Okay, so you know the area of this will be 4 times this. Okay, you can actually calculate that. Actually, it turns out it is also 120. And now we have completed everything we need, because again by analogy, okay, this will be 120, this will be 120, and so on. Okay, this will be 1 over 15, 4 over 80. Okay, but anyway, so finally, I told you ABT will have same area as ADXE by analogy, and same area as D, let's say ZC, and then same area as CYB. Okay, so these 4 big triangles will have same area, and let's calculate that. So area of ATB will be, you just add up everything, it will be 0.2. Okay, so this is 0.2, this will be 0.2, so ADXE will be 0.2, DZC will be 0.2, CYB will be 0.2 as well. So if you 1 minus all 4 triangles, you get 0.2. 0.2 is the area of this parallelogram TXE EZY. To find the orthogon, we just need to subtract 4 copies of 1 over 120. So finally, the orthogon is 0.2 minus 4 times 1 over 20. Okay, and you will get 1 over 6 as Paul Walker has shown you. Okay, so so this is the technique of area ratio. Okay, same height triangle. If you have 2 triangles with the same height, then the area is just the ratio of their lengths. Okay, So that's why I'm trying to find out all the ratios of these segments here, and then I can calculate. So yes, this is a complicated geometry problem, but it didn't make use of any super advanced knowledge, right? It's just area ratio. Okay, so let's end this video by giving it a difficulty rating. Okay, in this case, if it is given to the 8th grade, okay, this will be at least a 6 out of 9 or 5 out of 9. Let's give it a 6 because I haven't or 5 out of 9 anyway. And the character at this level would be Dara, this guy, which Sasuke needs his monster form to just kill it. Okay, thank you for watching.